we're going to calculate the geometric mean, but we're actually going to make a modification. It's going to be called the geometric mean rate of return is what we're going to calculate. Okay, and to calculate the geometric mean rate of return, okay, there's a formula for that. Okay, it says that the, let's say, the rate of return, the geometric rate of return, it's simply equal to, and I'll explain this, it's 1 plus R1, okay, times 1 plus R2 plus, times, okay, times 1 plus R3 all the way through times 1 plus Rn. Okay, looks complicated, okay, and it's the nth root of that, so it's this raised to the power of 1 over n, okay, and what we do also is we take 1 away from it, okay, so this is what's known as the geometric mean rate of return. So the geometric mean itself was just the product of R1 times R2 times R3 times Rn raised to the power of 1 over n. But what we're actually doing here is we're compensating for the negative values. Okay, so what we'll actually do is that after we calculate the returns, in this case we have R1 is equal to minus 0.5. and we have R2 is equal to 1.0. Okay, what we do is we calculate 1 plus these. Okay, so this becomes 1 plus minus 0.5. Okay, minus 0.5. Okay, which gives us, this is 0.5, and we do the same here. It's 1 plus R2, so it's plus 1.0, gives us 2. Okay, so now we have these two. Maybe I'll just make this a little bit smaller. Okay, actually what we'll do is we just do this out again. Yeah, we'll just start this again here. Okay, so we have the returns. We have R1 is equal to minus 0.5. We have R2 is equal to 1.0. Okay. At the end of year 1 there was a 50% decrease. At the end of year 2 there was a 100% increase. We want to know what was the return across the two periods, if that makes sense. Yeah. What I've said is that the geometric return is 1 plus R1 times 1 plus R2 all the way through times 1 plus Rn raised to the power of 1 nth, yeah, okay, raised to the nth root, yeah, okay, minus 1. It's this value here. So depending on how many returns we have, now in our case we've only got 2 of them, R1 and R2, so we just need to calculate this raised to the power of 1 over 2. We need to take 1 away from it. So in our case it becomes Rg bar is equal to, it's 1 plus R1 is minus 0.5, okay, that's that one, times 1 plus R2, it's 1 plus R2 is 1.0, okay, so we've done the 2 of them, okay, and that needs to be raised to the power of how many of them there is. There's 2 returns, so it's 1/2, and we need to take 1 away from that. So what does that give us? Let's do everything inside the brackets first. So it's 1 plus minus 0.5 is the same as 1 minus 0.5, which gives us 0.5, okay? And then here we have 1 plus 1 gives us, well, 1 plus 1 gives us 2, okay? So that gives us 2, okay? And that needs to be raised to the power of a half, yeah? And we need to take 1 away from that. So what do we get here? We have 0.5 times 2 gives us 1, and that needs to be raised to the power of a half minus 1. The square root of 1 is 1. And that's 1 to the power of a half is 1 minus 1, so it gives us 0. So actually the average geometric rate of return over this particular 2-year period is 0. It's 0% is the actual average return, which is what we'd expect it to be. Okay, so guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this example, which was trying to rationalize the difference between the arithmetic mean, the geometric mean as mean values, the arithmetic and the geometric mean, and also an important one, which is the geometric mean rate of return. Okay, I hope that this video was in some way intuitive, and more importantly I hope that was helpful for you, and thanks for watching. Okay, bye bye.